Hello, I'm Cathal Somers,
And I'm Deirdre Glenn.
your Teagasc Sustainability Advisors, and you're welcome to the Teagasc Environment Edge podcast number 45, bringing you the latest information, science and opinion to prove farm sustainability. With drones high on the list for Christmas gifts this year for both young and old, what practical things are people using them for? One innovative EPA-funded project has found a way to take a 2-litre water sample using a drone in order to help sampling become more efficient. A first for any research team in Europe. Senior lecturer and researcher in Freshwater Ecology and Biology, Dr. Heather Lally from the Atlantic Technological University Galway tells us more.
I actually have a background in environmental science, so I've always found this useful because it's quite broad. So I'm interested in lots of different things, but at the moment I'm predominantly focusing on water quality and chemical analysis of rivers and lakes. And then I'm also involved in a number of ecological restoration projects, and they're predominantly focused on blanket bogs here in the west of Ireland. So say, for example, two of the research projects I'm involved in at the moment are up in Wildnafen National Park in North Mayo. And there we're looking at the water chemistry of pools and lakes, but we're also looking at taking baseline data from Nafen Forest, which is a large area of conifer trees, roughly 4,000 hectares, that is due to be restored back to different habitats, predominantly woodland and blanket bog, over the next decade. So environmental science has been a good platform because it has allowed me to have quite a broad, I suppose, research interests or area of interest, I suppose.
So you're used to being out and about anyway, taking lots of samples, getting lots of hardship in all sorts of elements and areas. And I see you have a really unique project here. I suppose we're coming up to our Christmas time, so lots of people are going to be getting drones maybe for Christmas. But you're the first. You come up with a project where you're one of the first. You are the first people in Europe to take a 2-litre water sample using a drone. And I work a lot with catchment scientists, and they're always whinging about having to get into rivers and get into awkward places. So you've come up with a novel idea. So I suppose, can you tell me a little bit about about how common it is maybe, and where did you get the idea from?
Yeah, so I suppose it's coming off the back of being interested in taking water samples. And as you say, like normally you have to trek quite a bit to get these samples. But in 2017, the EPA issued a research call looking for research groups to give back proposals on whether you could develop a drone sampling monitoring tool. So essentially, could you get drones to go out and take water samples? And this, in their particular case, it was looking at it for lakes. So we put a proposal together, and we've been lucky to win that proposal. And from that, then we have built and designed a custom payload that attaches to a drone and then is able to go out and take 2-litre water sample from the middle of lakes. And I suppose previous research, predominantly in the US, has always looked at taking smaller quantities of water because they just wanted a trial, could it work? But here in Ireland, under the Water Framework Directive, we actually require quite a large volume of water to come back for our research labs. And so then we've settled on 2 litres for that. And we've been lucky enough to be able to get it, which is great.
Yeah, and was there some sort of a background in drones in the university already, or where did you come across it, or have you used drones before?
No, at the time, it certainly would have been kind of more of a novel aspect for us. We had kind of been using phantoms in terms of looking at monitoring seabirds and estimating kind of, or giving precision to kind of seabird colony counts, but we hadn't kind of ventured into kind of making devices to go with the drones, and we certainly hadn't kind of gone into the water sampling aspect of it. So it was kind of a new adventure for us as well. And I suppose when I started researching it, I did look a lot to the groups that were in the US. There was 3 key groups in the US at the time that were kind of had just started their journey. And so we kind of learned from kind of some of the limitations that they had picked up and then try to apply it to us. I suppose out of the groups at the time when we were making it, we would have been the first group that would have been from a water chemistry sampling background and an ecology background in terms of rivers and lakes, whereas the groups in the US are, they're electronical engineers, so they're into making the drone and making the attachments and not I suppose, overly worried about the water quality of the samples coming back, whereas we were really worried about that. And I suppose it allowed us to get something then that was able to match what you would do from a manual boat sampling protocol. So I think that's, I suppose, the advantage for us, is we understood the values coming back from the lab a little bit better.
Sounds like a marriage made in heaven, because when I was working research in Johnson Castle, we were looking at urine patches and using sensors to monitor different things. But the one issue we had was we didn't have that engineering experience, and it made things so difficult. And I see you mentioned in your project you're working with Professor Olaf Jensen from the University of Wisconsin. What was he using drones for? What skills does he bring to the table, I suppose, or knowledge?
Yeah, so Olaf is kind of looking at the use of drones in Mongolia, and here he was looking at seeing could you monitor kind of the largest trout species we have in the world, taimen, and essentially he was using kind of a phantom to fly back and forth over the river and see could you get images of this quite large fish. So then you'd be able to estimate, say, population size, but then you would also, from those images, you can get more data. So you can get the length of them without having to actually capture them. And you could also get the condition, what their health was like, from just getting an image of their skin, essentially. So he kind of had already been out in the field, and he had picked up quite a lot of experience again on limitations to what the drones can actually do. And so then when I met him when he was in Ireland on sabbatical, it was kind of like he was kind of, at least he had that experience of the field. And that was really valuable when we decided we wanted to go into the field here to trial our system. Making something in the workshop and having it on paper is nice, but when you actually go out to the side of the lake and you decide you want to put all of this money up in the sky that's not waterproof over a lake, it can get a bit like nervous. So his experience in that was really useful, and just getting me to think about other aspects I needed to take into consideration. But to be fair, things seem to be, things are windier in Mongolia. There's more sand particles in the air. So there was other aspects that I suppose we didn't need to consider as much. But wind is definitely an issue here for us, and rain. So I suppose it's just getting me to think a little bit further about what I was going to do in the field. So that was useful, to be fair.
So put an umbrella on the top of the drone.
Yeah, and try and not get it wet. So it's touch and go there sometimes as well.
So I suppose
Um,
the project, when you're going out to sample water, what does it look like? Where does it start? Do you go out with your drone? Do you fly it, or how does it work, or what's attached to the drone?
Yeah, so basically we have a DJI Matrix 600 Pro, so it's kind of quite a large drone. It weighs 10 kg itself, so like you're not going to be going too far with it. And then to that drone, we attach a custom-made payload system that would carry the water samples essentially back for us. So for all intensive purposes, it looks like a boat-shaped box underneath the drone that then it is flown out to the site. In terms of when you arrive at a lake, you set up the drone, you get your batteries warm, and then you trigger you attach the payload itself, and you put in your 2 water sampling bottles. We normally, prior to going on fieldwork, would have a location in mind. Normally these locations are 100 meters offshore, so you're not going out to the limits of where the drone can go, but you're making sure that you can retrieve it if there's an incident. We fly within 15 meters of the water column as well, so we're not very high up in the air. It's just enough for essentially the drone with the payload and a safety tether to go out across the water. And when we do get to the sampling location, we are landing the box essentially on the water column, and that gives us more stability to manage the drone, especially when you're out on, say, large lakes like we were with Loch Mask. We've got quite a lot of wind coming across it. So the drone hovers while the box then is activated from shore. We would activate a water pump to take the water samples. So these samples then are the 2 litres fill in series. And then there's also, in our particular scenario, we attached a YSI sonde. So that would take real-time data for us in the fields like pH, conductivity, temperature, and dissolved oxygen. And we were able to see that data when we were on the shore. So we knew, one, that the system was working and operational when it's offshore. And we can also see that the temperature, we can see the pH. So we know the system is operating correctly, and the values have been recorded.
That's super, actually. That just before you go on, I suppose
Yeah.
that's really super that you have real-time data straight away without going back to a lab. Because I know it's very applicable to rivers as well when you're looking at pH conductivity, so you can pick up pollution incidents in real time. Um, one other thing you mentioned, the custom payload. What is that? Just to explain to people.
Payload is it's kind of the technical term that's used within the drone world for anything that's attached to the drone. So you can attach anything. So like a camera would be a payload as well. So for us, it was our boat-shaped box.
Oh, massive, yeah. And so you get to that, you take the sample, and then what happens then? So you have your real-time data. Is that stored does that bounce back to a phone or a laptop, or is that stored within the drone?
I have it set up in both ways because you never know, like if you don't want to lose the data. So it actually saves on the device, on the payload itself through a YSI Go. And then it's also beamed back to a laptop, and then we download it straight away as well. So we make sure it's kind of like triple backed up, because everything's electronic on site. Then and you're dealing with water, you don't want an issue if the electronics get wet on the payload, or that your laptop battery dies when you're on the side of the shore. So I've set it up both ways to make sure that no matter what happens, it's going to be on the sonde, and then you can download that when you get back to the lab. And in terms of if it was being applied to, like, a large number of lakes, and you were doing 10 or 12 lakes a day, and you wouldn't need to be downloading it in the manner I was, but it'd be saved on the sonde. And then, at the end of the day or at the end of the week, you'd be able to download all your data when you get back to the office. So in trying to make it applicable in a real world consultancy scenario, I suppose, as well.
Yeah, and so you're out on the lake. You have your 2 liter sample. What happens next then? So I presume you have a container where it's stored, and then you fly back in, is it?
Yeah, so it sits in the middle of the payload to allow for the weight. And once the 2 bottles are filled, it triggers an overflow system, and we can see the overflow system then from shore. So we know that everything's ready to go. We've got all our data, we've got all our water, and then we bring the drone home essentially. And that's kind of essentially, so it's taken about 4 minutes for us to take our water sample, and then it's a 6-minute flight in total by the time you fly out, land, and then fly back.
Yeah.
So it's a very fast system compared to, launching a boat. You wouldn't launch the boat in 6 minutes nearly.
Yeah, and is that 2 samples you can take then when you're out, or is that 1 sample at a time?
That's 2 samples together. So you'll have 2 liters coming back, and then,
Yeah.
yeah, you can do triplicates then if you want, or whatever
Yeah.
number of samples you want. Yeah.
And you mentioned about the boat and the time. Is what are the main advantages to doing this? I suppose the resources for having a boat and all the health and safety stuff around it, is that one of the main ones, or is there other things as well, advantages compared to conventional methods of sampling?
From an operations perspective, definitely the fact that you wouldn't need to have a boat, you don't need all the health and safety requirements around it, and the insurance for actually having that boat out in the water are massive gains. Essentially, you also have a human resources benefit because you don't need as many people. Like, this can be operated by one person, which is a massive advantage. But I suppose from a key resource that we have found when we did our cost benefit analysis was that it was going to save time. Like, if you have 2 people out on a boat and 2 people using the drone, we found that when we compared our methodologies, it was 2.3 times faster. And that's a massive gain. If you were looking at the number of lakes in this country that you would want to monitor, or the number of rivers that you'd like to get monitored in a summer period. So this kind of has a knock-on impact then for costs, because if you can sample more lakes in a day and sample more lakes in a season, then you're getting better value for money on those national monitoring programs. So it speeds everything up. And if you can sample those sites, I suppose, in a quicker way, and you get your analysis to the lab, in 2 to 3 days, you're able to tell if there's an issue. So you're able to have a kind of a quicker response time for particular locations that might be having an impact. So I think in those scenarios, it gives quite a number of benefits, to be fair. Yeah.
If I'm sitting in the EPA now and I'm director of the EPA and I'm looking at this type of work and what you're saying to me now, I'm getting very excited. You've seen the EPA water quality report come out. It's not great. We've a lot of work to do by 2027 to meet our targets. And they've called for additional resources to be put into monitoring and obviously assessments of different areas. But you could effectively go out, and we're all familiar with, I suppose, the guy or girl on the bridge leaning over, taking a sample out. Now you can head out with your drone and you can fly it up at different parts of the river without getting out of your Jeep for kilometers, I presume. Take your samples back in really quickly. The EPA must be getting very excited with the potential of this.
Yeah, like it's definitely going to be a massive kind of tool that they'll be able use, I suppose, in the future. The biggest ability, of course, in the future will be for large lakes where you can maybe potentially be on at one location and get a number of samples from around the lake without having to drive around it. And that'll be of massive benefit when you look at large lakes here in the west, like Corrib, Lough Mask. You'd be the whole day sampling it. And I think it'll also allow more lakes to come into national monitoring programs for the EPA, because now you'll be able to get to sites that don't have slipways, ones that are remote in mountainous regions, and certainly kind of for those type of lakes where we probably don't have any information, kind of seeing what is their water quality up there. So I think it would be really beneficial. They'll use, I suppose, a number of tools as they go forward for the next round of kind of water framework directive monitoring programs. And I think drones will be useful. If initially they don't use them for water sampling, there's a camera on these drones, on all drones, so they're still able to pick up quite a lot of visual data when they're out and about using them. And that would be useful in terms of looking at critical source areas, point sources, and then even more so just from taking imagery for nuisance algae, invasive species. So there'll definitely be a tool we'll see the EPA use. If it's not for water sampling, they'll certainly be able to incorporate them into their monitoring programs.
I think if we see drones now delivering cups of coffee to people, I'm sure they're going to be using them for this type of work. But is there a rollover project that you're going to be involved in, do you think, or is it stopped?
At the moment, we don't have a rollover project. We have trialed it in the marine environment kind of ourselves, because one of the things was we were focused on lakes for that project, and it would be great to see like how applicable it is in other environments, and particularly for estuaries and for rivers, where you've got fast moving water, and seeing how stable we can get it, and does the sampling methodology hold up there. So I think we have plenty of ideas for the next round of funding.
I can see the practical application for this working really well, actually. For the type of work that we do, you're on just one water body, and they're constantly going bridge to bridge to bridge, looking for conductivity, looking for different things. You could have all that done really quickly. Even if you never took a sample, you could just dip in the river, see what's going on, go to next point. Yeah.
And now in the last 2 years with COVID, like we've got real time nitrate and phosphate sensors.
Yeah.
So actually I'd take off the ones that are on it and put on those type of ones. And then, as you say, you don't even need to take a water sample. You just dip it in, and then you're able to get your nitrates and phosphates straight away.
You have real-time sensors going on there now as well. Are they accurate, or how accurate are they compared?
Yeah, no, they're really good. Yeah, because we actually sent all our samples to the lab, including the pH and everything.
Yeah.
And everything comes back the same. So it worked really well. But we use the exact same system on the boat. So sometimes when people are making methodological differences, they have a different probe on the boat. So we used everything the same. But as well, I wouldn't see them as replacing somebody. And I think that's also the other side of that coin. People are worried if they start using them, they won't need people. But like at the end of the day, they're only as good as the guy flying it and the guy interpreting it on the other side. And they're still skills you need to have. So I don't think it replaces people. It just adds to what you can do.
Anyone that's into technology like me, scientists, would be delighted doing that kind of project work. So look, I really enjoyed the chat today, and I think it's great what work you're doing, and I hope to see some drones flying around the future doing some extra work for us, and wish you and your family a very happy Christmas.
Same to you, Cathal. Thank you.
That's it for this episode of the Teagasc Environment Edge podcast. We'd like to wish all our listeners a very happy Christmas, and thanks to Dr. Heather Lally, Senior Lecturer and Researcher in Freshwater Ecology and Biology at the Atlantic Technological University Galway, for joining us on the show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to the Teagasc website at teagasc.ie. I'm Cathal Somers. Join us next time for the Teagasc Environment Edge podcast, signpost to farm sustainability.